Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode 55, Supplemental. So at the end of episode 55, my mic stopped working. Apparently when you pause the recording in OBS, sometimes the microphone just stops working. So this is just going to be a short, we're going to look at the data here. So in the last video, we collected some data from running bubble sort, and we ran it with this many elements, and I got the data here. So the max runtime, minimum runtime, and average. All this is in microseconds. And this is without early exit. This is with early exit. We have a comparison count, the expected comparisons, and some graphs created. The things to note here for the first case here, well, for all of them, for 10 elements, in fact, even 100 elements, hard to see much information. The reason for that is that it increases that it's dealing with a lot of interference from other things running on the computer. My recording software, whatever I'm running, it's competing with that for resources, and in doing so, that can cause fluctuations. The in this case, we look here, and there's some fluctuations, maybe not a ton, but it's a little hard to see it increasing. Like the first one here, it actually you can see it increases 10 squared times, so 100 or 10 squared is 100, right? So it increases 100 times between them, but after that it gets a little harder to follow, and we're not expecting a perfect, and we did not get perfect. Same thing over here. If we look at the average, the most part it didn't follow 100%. Some of it's a little alright. And when we look at the graphs, this one here is the first one there. It is the average case without early access, so it's this one. And just looking at it, it's sort of, you could see that as being a quadratic curve. So you could see it going up sort of as you expect. As you get more, it'll start looking steeper and steeper, and that's sort of what we expected. And you will notice here for average with early exit, we got the same thing. So that's actually pretty good. We got what we expected. Interesting thing here for comparisons, we got exactly the same comparisons as we expected, so that makes sense. So without early exit, we have to search through every element in the array, and we have to complete the search. So we did some math here on how many we should get. One of the summation formulas, and we get the same values. So we got what we expect. With early exit, we do a little better for the most part, and we did it better for all the cases. Yeah, I believe all the cases were better, even if just slightly better. And you can see right here is an outlier. Since we're using random data, the array we got here that we sorted ended up being really, really good, actually. It was already mostly sorted, and that really drove down the number of comparisons. So just one thing to keep in mind is occasionally that can happen with random data. So that's in here, and it took probably, what is this? This is 11 seconds. 11 seconds times 2 times 100. 111 seconds. So a couple minutes to run. 10 minutes or so to run. So I did not run it again, but there's the value there. So there is some outlier there, but I don't think it affected us too much. For best case, I just sorted the array beforehand, and then we resorted it with bubble sort. And for the without early exit, we don't see a lot of difference. The comparisons are the same. Numbers are faster, and in fact, looks about a fifth as fast. So pretty significant speed up, but roughly the same. So we can see here on its graph, this one, it still ends up looking like a parabola, albeit much smaller one, but it's still going up in the expected direction. Not so here. So here looks like this. So what's happening here is all it has to do is run through the list one single time. So all it has to do is go through, make sure everything's sorted. It doesn't make any swaps, and because it doesn't, we're good and we're done. And in that case, we get the values one less than whatever our case is, so it has to check every case still to make sure it's good, but every case minus one, so make sure the array's sorted, but that's all it has to do, and then it's done. And in this case, we get really fast, but again, we're influenced by the other things running in the computer, so you see it's all over the place. The 100,000 cases smaller. Some cases it grew like 50,000 to 10,000 was actually faster. And if you look here, the slowest was 5,000 was slower than the 100,000. And although it seems like outliers, and it was, it creates this weird graph here. Notice something interesting here though is it suddenly doesn't look like there's much of a curve here. There is here at the front. It's all weird here at the front, but it sort of looks like it was straightening out here, and that's to be expected. So when you get into best case, all it's doing is it's linearly going through the list, so it's linear instead of not exponential, polynomial. So it's closer to a straight line, and if we increased it more, we should see it start being straighter and straighter, and that's what we expect. And the last graph here is the average comparison, and if you notice it sort of grows in the same ballpark as well. Again, the numbers are smaller, but it's sort of growing polynomially as well. So we sort of got what we expected, and all the numbers ended up backing up what we would do after we fixed the problems last episode. So I think this data here is what I wanted to gather, and we wanted to put the program together. So I think this is a good start. So we'll go ahead and call it there. Again, this will be a supplemental to the last video, so it's really short. We're only going to be about 8 minutes long, so we'll go ahead and call it here. So thanks for watching, and have a wonderful rest of your day.